Hello and welcome. My name is Gary Winter. In this video, I will show you how to move your code to events to arrive at an event-based architecture in Microsoft Dynamics 365 Business Central. Let us have a look at the agenda of this video. We will first briefly look at the scope of this video. I will then give you an introduction to events, after which we are prepared to look at practical examples of how to move code out of Microsoft Base App standard objects and into our own objects. This video is about strategic decisions on moving an existing traditional code base to an event-based architecture, and first and foremost about how to prepare for that in CAL. It is about the transformation process and not yet about working in Visual Studio Code AL. If you want to learn more about developing extensions in Visual Studio Code AL, please have a look at other videos in this series, which are about working in VS Code, handling events in VS Code AL, and implementing table and page extension objects in VS Code AL. In this video, you will learn how to lay the groundwork for that. If your goal is to transform your existing traditional code base, the first step is get your CAL code ready for Business Central extensions. You do so by minimizing your impact on the base app, which will also boost the updatability and lower coupling for your on-prem code base based on Microsoft Dynamics NAV 2018. By the way, I would recommend to watch our video on the structured development methodology before jumping into event-based architecture if you have not already done so. The goal is to move all of your code, which is inside Base App objects, into objects of your own by leveraging events. If there remains code which cannot be moved easily, you will need to develop a strategy for refactoring that code. Let us first discuss why we even care about events in the first place. Events allow us to react to what goes on inside the Microsoft Base App and to enhance that business logic. An event-based software architecture has a zero footprint in the base app. It thus improves the updatability of our own code tremendously, and it decreases the impact of changes in the base app. So an event-based architecture is a good thing as such. But with Microsoft Dynamics 365 Business Central, the main point is that it enforces event-based coding for Microsoft AppSource. An extension that gets published on AppSource must have no code customization in the base app. Vertical and horizontal add-on apps or connect apps do not allow any direct changes in base app objects. Visual Studio Code AL extensions can enhance base app behavior only by reacting to events. So which events can we react to in the first place? There is a comprehensive typology of events and a more simplified one. Let us have a look at the official Microsoft differentiation between event types first. There are system and application events. System events are split into global events and trigger events. Global events are events which are automatically raised in code unit 1, such as on before company open or on after company open. Trigger events are split into table and page trigger events. A system event of a table is automatically raised whenever a database transaction is triggered and whenever a table field is validated. All of these trigger events come with an on before and an on after event that you can subscribe to. To give you an example, there is an on before insert and an on after insert event on table level. This is true for modify, delete, and rename operations as well. On field level, there is an on before validate and an on after validate event for each physical field in the table. At field trigger level, the difference is that the on before validate event is called before any code in the respective validation trigger of the Microsoft Base App. And the on after validate is called after this base app code has been executed. If there is no code in the field validation trigger of the Microsoft Base App, there is no difference. If there is code, you need to decide whether your code should come before or after the base app code has been executed. To be perfectly clear, that is your only alternative. You cannot execute code in between base app code, and you can also not execute code instead of base app code. There is no override mechanism. When we look at CRUD triggers like onInsert, onModify, onDelete, and onRename, there is a subtle but important difference. The onBeforeInsert trigger is executed before the base app code in the onInsert trigger, and the onAfterInsert trigger is executed afterwards. But what is very important to take into account is that the onAfterInsert trigger gets fired after the record has already been written to the database. So if you want to use the onAfterInsert trigger to modify the record that has just been inserted, you need to read it again before doing so. In any way, it is not good practice to be performing any modifications on the record itself after it has been written to the database. The onAfterInsert, onAfterModify, onAfterDelete, and onAfterRename triggers are designed to give you the chance to perform any action in regard to associated tables. Page triggers work in much the same way, giving you access to system events on pages like on OpenPage or to page field validation events. Most useful is that they also give you access to actions defined on pages. Application events follow a different concept than system events. Application events need coding in the Microsoft Base app to be accessible. Since you cannot put any code inside the Microsoft Base app, you can only react to application events that Microsoft has provided itself. An application event is designed to enhance business logic rather than to just react to changes on field and table level. The Microsoft Base app publishes an event inside a Base app object and raises it at the right point in its business logic. The developer is able to subscribe to that event and enhance the business logic. There are two types of application events: integration events and business events. To demystify, program behavior is exactly the same, regardless of whether an application event is published as an integration or a business event. The difference is more of a philosophical kind. An integration event may change in between versions. When, however, you publish a business event, you indicate that you establish a formal contract and promise not to change that event in future releases. As I said before, you can greatly simplify the event typology, which may give developers a better initial access to the concept. You can think of only two basically different types of events. System or trigger events are events which are raised automatically because a field has been validated or a database operation has been executed. You will find no code in the application for system events. They just get fired. An application event, on the other hand, is any event which is published and raised through code. The subscription mechanism for both kinds of events is the same. On the right-hand side of the screen, you see a few examples for system or trigger events on the one hand and application events on the other. The examples for application events come from Code Unit 80. Please be aware that while the onValidate trigger is a standard system event, there is no event which reacts to onLookup, neither in tables nor in pages. This overview summarizes all table trigger events. You see how every event has an onBefore and an onAfter component. They are listed in alphabetical order. You can also see which parameters are passed to the subscribing functions. The onBeforeValidate event and the onAfterValidate event are of special interest. If you subscribe to a validate event, you will need to specify which field validation you actually want to subscribe to. If any integration or business events were defined for this table, which happens to be the currency table, they would also show up in this listing. This is the equivalent listing for page trigger events. The onBefore-Action event and the onAfter-Action event will require you to specify the action that you want to subscribe to. The link on the bottom of the screen leads to a complete explanation about the concept and implementation of events. Let us jump into a practical example of how to shift code from an object in the Microsoft Base app to an object in your number range by leveraging events. As you can see in this example, there is code customization in table 18, the customer table. At the end of the onInsert trigger, a method is called which obviously starts an onboarding process for the new customer. This calls a function in the customer table, which is a method declaration. This method declaration points to a code unit in your own number range, which actually implements the function. Again, if you're not familiar with this architecture, you may want to have a look at the video on structured development methodology. In an event-based architecture, this code cannot remain as it is. Both our code customized function on the customer table and its reference in the onInsert trigger need to be moved out of the Base App table 18. To move the reference in the onInsert trigger out of the Base App table, we create a so-called handler code unit for the customer table. In this code unit, in our number range, we create a function which subscribes to the onAfterInsert trigger of the customer table. This function then calls the method startOnboardingProcess. Please watch out for a few things. First of all, there is the parameter runTrigger. This is passed from the system event to the subscriber. If you subscribe to a system table event, the subscription is always executed, regardless of whether the validation or data operation has been invoked with the parameter true or false. So the onAfterInsert system event will be fired even if the customer has been inserted with cust.insertFalse. The Boolean parameter runTrigger shows you whether true or the default false have been used in calling the system trigger and allows you to react respectively. Likewise, you should always think about what you want to do if the record is just a temporary record. There are a lot of methods that you do not want to execute on a temporary record. This is not only true in this specific context, but you should make it an integral part of your considerations how you want to react if runTrigger is false and is temporary is true. You also see in this example that the event handler code unit catches the event, but there is no real business logic coded here. All the subscriber does is check whether it wants to react to the event and then call the appropriate method. The declaration of the method was formally done on the table itself. This also needs to be moved out of the Microsoft Base App object, so instead of declaring the method on its original class, we create a customer class code unit which contains all of its additional methods. These will then point to the respective method code unit for execution in much the same way they used to do from the customer table before. So originally, we had these three elements. 1. A method declaration on the customer table within the Base App. 2. A method code unit which implements the method in our number range. 3. An additional line of code in the onInsert trigger of the customer table within the Base App. What we end up with after moving the code to an event-based approach is the following. 1. An event handler code unit for the customer table in our number range. 2. A customer class code unit for the customer table in our number range. 3. A method declaration in the customer class code unit. 4. A method code unit which implements the method in our number range. This is the only part that remains unchanged. 5. An event subscriber which catches the onAfterInsert event of the customer table and calls the method declaration in the customer class code unit. We see that the business logic as such, the method code unit start onboarding process, remains entirely unchanged. It's just the architecture of what gets called from where that changes around it. Now let us look at this example in a step-by-step approach. We have based this example on the assumption that you are coding according to the structured development methodology. In that case, start onboarding process is a function on the customer table which declares a method that points to a code unit of the same name. The general architecture works in the exact same way, though, if your code looks different. First of all, you need a code unit called customer class, in which you transfer all of your additional methods for the customer table. You either create this class code unit, or you add the method to it if you have already created it before. You need one class code unit for every table which you have developed additional methods for. So there may be a customer class code unit, a vendor class code unit, an item class code unit, and so on. Add a suffix to the code unit name, which refers to your extension in order to make the name unique, because other extensions may have added their own customer class code unit as well. In our example, we have chosen the acronym MYC. You then need a code unit called Customer Event Handler, which handles all of the events of the customer table that you need to subscribe to. You either create this event handler code unit or you add a subscription to another event if you have already created it before. Again, there should be one event handler code unit for every object the triggers of which you need to subscribe to. So there may be a customer event handler, a vendor event handler, or a sales order event handler if you need to subscribe to an event on the sales order page. Suffix the code unit name in exactly the same way as you have done with the class code unit. Let us summarize a few intrinsic characteristics of an event handler code unit. An event handler code unit should only always refer to one object. So you need one event handler code unit per object that is relevant for you. The subscription functions should have the exact same name as the trigger or the event publisher it refers to. So they should be called onAfterInsert, onBeforeValidateName, onOpenPage, and so on. Since the context is established through the fact that the event handler code unit only refers to one object, you don't need to duplicate its name, as for instance in customer onAfterInsert. As we have seen, there is no business logic inside an event handler code unit. The event handler only subscribes to an event but does not contain any business logic code. It points the execution of the method to the respective class code unit. We have learned that we should always respect the runTrigger parameter and the fact whether a record is only temporary or persisted in the database. Let us now look at the basic characteristics of a class code unit. Much like the event handler code unit, the class code unit always only refers to one object, in this case, a table object. It is not more than a collection of additional methods that you have developed for the original class, in our example, the customer table. Since there cannot be any individual code in Microsoft-based app objects anymore, they need to be moved from the table to an object in your number range. The class code unit also does not contain any business logic. It just declares the additional methods and points the execution to the respective method code units, which have been called from the original table before. Needless to say that all of this can be handled in a much cleaner way through table extensions and page extensions in Visual Studio Code AL. Let us briefly focus on naming conventions. A class code unit name consists of the following elements: the name of the original table, for instance customer, the epithet class, and your app acronym as a suffix to make the name unique, for instance MYC. This leads to the name customer class MYC. Suffixing the app acronym is preferable to prefixing it. If you prefix, all of your variable declarations will start with MYC, making the code quite unreadable. Unfortunately, there are severe limitations to the string length of object names. This will make odd abbreviations necessary every now and then. An example would be the financial charge memo header class. It is advisable to take the time to look for established acronyms on the internet. Also make sure to always include the epithet class so that you can filter easily on all class code units. The naming conventions of event handler code units are much the same, so that you arrive at a composite name of Customer Event Handler MYC. Limitations of the string length of object names have an even greater impact here, since the epithet event handler runs longer than the epithet class. Make sure to always include at least the abbreviated form handler so that you can easily filter on all event handler code units. This example shows a few class and event handler code units. Please notice that the object IDs are just by way of example. Object IDs will come from your own unique cloud number range in the 70 millions if you run an extension that is only available in the cloud. Or they will come from your own CFMD number range if you have a CFMD solution that you can run in the cloud and on-prem. Or they will be in the 50,000 to 99,999 number range if you are a value-added reseller writing tenant-specific extensions. If you already have an on-prem product developed in CAL that you want to turn into a Business Central app, you should consider this two-step approach. Redesigning its architecture to an event-based approach in CAL is a very good preparation for moving it completely to a Visual Studio Code AL extension. It will teach you how to approach the event-based paradigm, and it will reveal any issues in your code that you will need to refactor. Afterwards, it will be much easier to lift your event-based on-prem product to Visual Studio Code AL. This concludes our course on moving your code to events. To learn more about how to build and publish apps with Microsoft Dynamics 365 Business Central, follow the link on the screen. Thank you very much for your attention.